Welcome to the Aerospace Advantage podcast. I'm your host, John Baum. Here on the Aerospace Advantage, we speak with leaders in the DoD, industry, and other subject matter experts to explore the intersection of strategy, operational concepts, technology, and policy when it comes to air and space power. So if you like learning about aerospace power, you are in the right place. To our regular listeners, welcome back. And if it's your first time here, thank you so much for joining us. As a reminder, if you like what you're hearing today, do us a favor and follow our show. Please give us a like and leave a comment so that we can keep charting the trajectories that matter to you most. This week, we're going to take a look behind the scenes of one of airpower's hottest topics, collaborative combat aircraft, the Air Force's new buzzword for next-generation UAVs. There are a number of companies involved with building these aircraft, names you hear frequently on this podcast. General Dynamics, Lockheed Martin, Boeing, and Northrop Grumman are obvious ones in the mix. But there's also a company known as KRATOS who is a major player. They got their start in the target drone business and then pressed forward with far more advanced designs that really helped people rethink the art of possible when it came to the next step for UAVs. In fact, their Valkyrie design has become synonymous with the CCA concept. So today we have Robert Winkler of their team with us, and he goes by the call sign Otis, and he's going to help us better understand what it's like to be in this space, to develop the research, engage with the military service branches as they work to define new operating concepts. And let's not forget, they have to ensure the bottom line is met from a business perspective because you can't produce airplanes if you don't meet payroll. So Otis, welcome to the show.
Thanks for having me.
And we also have our very own Doug Berkey of the Mitchell team here with me today for this conversation as well. So Doug, welcome back to the Aerospace Advantage.
Hey, Slick. Thanks for having me. It's always fun to be on. And, just echoing what you're saying, this is a super important topic. I mean, we talk to folks in the government side a lot about this, but I really wanted to highlight the industry component of this as well, in that the government can come up with concepts and the strategies and all that, but you still need to build the tech to go manifest that. And so our guest today is really a unique actor in this space. Otis served in the Air Force as an F-16 fighter pilot. It included a tour with the famous triple nickel. And we just saw Otis smile there about that. And the best F-16 squadron, he tells me. And he wrapped up his tenure as the Div Chief for Air Force Legislative Liaison, the weapons branch. And those guys, I mean, that is the most important element, in my opinion, because it's all of the heavy capital investments, the aircraft and munitions. Back when Otis was doing it, included space. And so that really is the heart of where the Hill is focused. And he was the Air Force's key go-to guy there, working with the authorizers. And then after retirement, he was in industry for a bit and then was asked to serve as a professional staff member on the Senate Armed Services Committee, where he focused on aircraft for all the services and then space as well. And so again, just a tremendous bit of knowledge there that he gained and imparted to the position as well, and saw a lot of things uniquely. And then departed the Hill last year and is now a key member over at KRATOS. And so, the big picture here, Otis isn't just some BD guy selling an airplane. This is a guy that has tremendous wisdom across the spectrum about combat aviation, and he's a huge air power expert. We call him all the time for advice and all. And so we just wanted to bring him on board here today to talk about this part of UAVs and the business side and where the tech is going and all that. So Otis, thanks so much for taking the time.
No, thanks for having me again. And I'm real excited about this important topic. UAVs have been around now for going on more than 20 years, and we're evolving. And I think in this space, there's a lot of room for taking advantage of both technology, disaggregation, really, and an affordable mass.
Yeah. And, Otis, well, first and foremost, I'd be remiss if I didn't say one screen.
Always green.
As a nickel guy, but again, your experience being a weapons school guy and commanding a combat fighter squadron and doing everything else you've done is what makes having you here so important and to talk about this topic. But I want to take it back a few years. Where were you when you first heard about UAVs being used in combat? Was it Kosovo, Afghanistan, and what were your initial when you saw the technology?
So I think initially, growing up in Allied Force, I think there was some discussions about UASs and the capability of UAVs, but I think I distinctly remember the first time that I ever saw full motion video. It was I was flying in operations in Southern Watch at a PSAB. I got pulled over as a weapons officer to go to the KAC because there was a crisis that was evolving and see if they needed any help. And it turned out it was Operation Anaconda. There was a helicopter that had crashed, and there was an MQ-1 that was sitting over the crash site, giving a bird's eye view to what was going on the ground. And it dawned on me that if it was a manned aircraft that was sitting over the top that had weapons, or an unmanned aircraft that had weapons, it would have had a significant impact in the initial stages of that battle. Obviously, air power over time had a huge impact on Anaconda and resulted in turning the tide of that and coming out victorious. But in the early stages, that the one UAS that was sitting over the top that I was watching didn't have any weapons. And it dawned on me there for the rest of my life. I thought that if you fly in the air in a combat environment, you should always be armed. And that really has formulated my opinion of the benefit of UASs and UAVs and the capability that we need to get out to the warfighter.
So I want to dig into this a little further. I mean, F-16 pilot, and if you look at that airplane, you guys are multi-role to the extreme. I mean, you've got the air-to-air mission, air-to-ground, you even do ISR with the targeting pods and things like that. And so that's a ton of training. There are a lot of currencies you have to keep with that. How would you compare that level of complexity to what the early UAVs were like? I mean, you talked about they didn't have weapons initially and all that, but how has that evolved and how did you see it initially?
Yeah, so I think that when you have a multi-mission capability, right, you tend to break it down into making a building block approach as you start in your training. You start by learning how to put the aircraft where you want it to be, both in an air-to-air, a BFM environment, and then in air-to-ground in the surface attack, kind of benign roles of being able to put your aircraft, your sensors, and your weapons where you want them at any given point. And then you grow from there and do a missionized kind of capability, flying the aircraft at the same time as employing your sensors and your weapons, and all the way up into a missionized kind of scenarios where you're actually practicing working as a team, working as a 4-ship or an 8-ship or as an overall mission commander, and employing the weapon system that was meant to be against an adversary. And I think that I saw the same thing from the outside when it came to the MQ-1 and the transition it made from being a pure ISR platform of watching the enemy with a unique capability of being on station for a really, really long time. It gave great capability to do pattern of life analysis and to do tracking in that ISR role that you didn't get at the time from any manned aircraft or from any space-based assets.
So, Otis, I've got to ask, you obviously saw the MQ-1 in a critical moment early on. So when did you start to see that UAVs were beginning to expand from this long distance, remotely controlled aircraft, of course, to the very powerful ones, but developing into something more? And as I recall on your timeline there, that weren't you in the legislative liaison position when Skyborg, when that program kicked off?
I was, and it started out as what was called LCAT, the low-cost attritable aircraft technology, and it was a unique, can we take an aircraft and make it unmanned, make it runway independent, make it a fighter-like capabilities, and do it at a cost that you could have affordable mass. And so that was the beginnings of the program that turned into Skyborg and became an AFRL Vanguard program, so one of the most important programs that AFRL did that bridged from the modern technology all the way over into an operational concept. It was interesting.
So what was pushing the Air Force this direction? I mean, you just said affordable mass. Was that it, or were there other attributes they were trying to pick up?
So I think there were a number of things that came up. One, it was the technology and the sensors that were getting smaller and more capable. We had the idea of mosaic warfare, the disaggregation of capabilities that can come together and make things better by the sum as opposed to the individual organic capabilities. And then some really unique war games that came out that played this idea of man-on-man teaming and augmenting manned aircraft for affordable mass that had game-changing capability to be able to apply pressure to the enemy.
So, Otis, I want to fast forward just a little bit. So a few years later, you're on the Hill in the Senate. Skyborg is a major priority for the Air Force. How are you seeing things evolve?
So one of the biggest things that I saw was the idea of, one, Skyborg proved out. So we could make an aircraft that had all the attributes of a fighter that could carry 1,200 pounds of payload, of usable payload, and fly in formation, keep up with a strike package, have the survivability of any of the other aircraft that were in that strike package, and relieved ourselves from the burden of manpower that we were, I won't say stuck with, but in the initial phases of, not really understanding how we were going to use unmanned aircraft, we did what happens in most times, which we throw people at it, people doing great work to figure out the right way to do things. But it turned out that it was about 200 people to support one combat line for an MQ-1 or an MQ-9. And that doesn't scale when you get up to thousands and thousands of these. So I think the man-unmanned teaming, working, initially with deterministic AI and then moving forward to non-deterministic AI, really made all of that come together in a culmination of this is something that we can actually field in the next 3 to 5 years, which is what really got people in Congress excited.
So I remember when I used to come up talking in the Senate, and a huge thing that was both bothering us a lot was the shrinking inventory of Air Force aircraft. And the service was really spiraling down. I mean, it's still happening where the capacity keeps going down, and they say, oh, we'll get better in the future. And we haven't seen the future yet with that recovery curve yet. So how does that impact your thinking when it comes to next gen UAV technology and some of the drivers?
Well, like we talked about with affordable mass, Congress put forth that the Air Force needs 3,580 combat coded aircraft, and they wrote it into law as a policy of the United States. We're not even close to that right now. I think we're about 1,000 aircraft short and on the downward slide. The only way that I think we can get there, right, and I think that was recognized across the board on the Hill, was having something that is a lower cost, same capability that can augment, not replace, but to augment our manned aviation aircraft. And when they looked at all the classified wargaming, it really did move the needle significantly against our near peer adversaries. And I think that those two things together, we proved out the tech with Skyborg, with the Valkyrie, the XQ-58. And then we have an operational concept that was developed and war gamed out. And those two individual pieces coming together really made a difference of something that we could field in a relevant timeline.
So, Otis, during this time, were there any like really big moments for you in this period? Did you see any key, technological gains that really suggested that, the technologists were onto something for next gen UAVs?
I did. I think that one, like I said, was the manufacturing. We can now manufacture aircraft at, less than $1,000 per pound. I didn't realize it until I started working up on the Hill, but we end up buying aircraft by the pound in the United States and really across the world. And so they all have different capabilities, right? But in the end, the heavier the airplane, the more expensive it is in general. And there's a curve that you can plot out all the aircraft in the last 75 years, and they end up matching on that curve. Until this, right? Until we actually made the Valkyrie, we moved significantly off of that curve. And that was one big wake up moment, is that, we can actually invert the cost curve to make that more expensive for the enemy to actually stop us from doing something than it is for us to build the weapon, in this case, the airplane, to impose our will on the enemy. And then, so the manufacturing part was a big piece. And then the idea of disaggregation, right? And that mosaic warfare that DARPA pioneered of pulling things apart and being able to make them connected, bringing them back together in an overall common operating picture that everybody can use and everybody can exploit with their weapons and sensors. So not everybody has to have all of the capability on every single platform. And then finally was DARPA ACE, honestly, and the idea that AI can actually augment a human, a pilot in an aircraft, at a relevant time scale where it's not, science fiction 20 years from now, but it's something that you can actually demonstrate today. Those three things together, I think, were the big wake-up call for me as this is the way of the future.
Yeah, it's cool to hear you say that, because I saw different advantages of that occurring, and obviously we were very involved with Mosaic, working for DARPA on that project. But to hear you put it in that context, that really brings the pieces together well. So you're up on the Hill, you're changing the world in good ways, but the time came where you wanted to move on. Why KRATOS? You could have gone anywhere. I mean, a guy with your background is a pretty valuable commodity here in town. So
I really liked the culture at KRATOS, the ability of not doing the same thing, but actually being on the forefront, in this case, of this manned-unmanned teaming, jet-powered, fighter-capable drones that are going to be augmenting our manned aircraft. And they are on the leading edge of that moving forward. And I wanted to be part of that, right? I recognized, or I felt like that was really the way of the future, and I wanted to be able to join in and help them and help us now shape what that looks like in the future, and then also help the Air Force and the warfighter field this as quickly as possible to be able to get it out and make a difference against Russia and China. At the same time, KRATOS also, my portfolio on the Hill was really space, aircraft, and hypersonics, as well as warfighting networks, so the comms, data links that go back and forth. And interestingly enough, KRATOS does all of that. And so it was a really nice fit for me personally and professionally.
Well, Otis, I got to ask you this too. Can you give us a baseline here? And of course, I don't want you to go into anything classified because I know you guys are doing some really high speed stuff there. But, what can you tell us of what you are doing and what you guys are doing at KRATOS? I mean, the Valkyrie is obviously super famous. How has that evolved from version 1 to what's flying today?
Yeah, so it's a great question. And the KRATOS team is pedaling really fast and try to squeeze out as much capability as possible, but still maintaining that low cost price point. And we're talking about a $5 million airplane, versus the other things that are out in the field that give you greater than 3,000 mile range, 1,200 pound payloads, and flies at near supersonic speeds. So it's pretty awesome. But like most things, right? It started out as a basic aircraft. So version 1 of the Valkyrie was just an aircraft that you needed to fly to demonstrate its flight envelope, to go out and do the normal developmental test that you do on every single other aircraft that has ever been invented by the United States or anybody else. So that was the first one. And now that you expand out the flight envelope, right? But eventually you need to missionize it. And so that's things that we've been working on, right? You want to make this into an open system. So one, we have the airplane now, we've expanded the flight envelope to the maximum takeoff weights, right? Again, with runway independence, so we can launch this thing from anywhere in the world and recover it back via parachute. So you don't have to be on a runway, because you can imagine, I think most of our listeners can imagine the fact that at a red flag, you're bringing back a good number of aircraft to one location that's not under fire, right? It's not being attacked, holes in the runway, contested logistics or any of that. And it's still a major operation to get everybody back. Now you can multiply that, with every manned aircraft, hypothetically, from Barry Kendall as, 5 to 6 unmanned teammates that are flying alongside of them. So you get 20 airplanes coming back. That's 100 total or 120 total people that are coming back into your platform. Most of them unmanned. I'm not sure how, in my mind, as a mission commander, I could make the takeoffs and landing recovery process work. We fix that by just moving it off. You recover those jets somewhere else so you don't have to worry about runways anymore. So they've expanded that envelope out. And then with the open systems architecture, now you can take any AI and any sensors and drop them into the aircraft to either optimize it for the mission set that you want to use, or upgrade the sensors, or change out the AI to a different type of AI as the AI moves along and progresses itself from that deterministic to non-deterministic. So it really is form, fit, and function, still an airplane, but you're able to drop in all the capability, which it has to be, you have to do that by design. The open mission systems, you can't do that after the fact.
So I just want to pick up on something you're saying. So you talked the open architecture of the aircraft. And so you guys are an airframe manufacturer. KRATOS builds the airplane. It interfaces with the AI that really is kind of the brain that operates this thing. And so can you explain to us how that relationship works?
Sure. So you can think of it in a couple of ways, right? And it's fascinating to me. There's a big argument that happens between the engineers, the AI engineers and the airplane engineers, as to where the interface happens, right? But ultimately, if you're doing it right, you want the AI to be in control, right? Think of it as the mission commander of the aircraft. And then you have the airframe side that does the actual flying. So you don't want the AI to say, hey, I need to put my sensor over here. I'm going to make the airplane, do 12 and a half Gs to get over there and then structurally break the aircraft. So you have an autopilot that's built into the aircraft itself that the AI would interface with. And then you have the sensors and the mission systems that the AI interfaces with the idea you optimize both, but you have the capability of taking that AI engine out, right? Because it's interfacing with an open system. So all the interfaces themselves are all known and able to be picked up by any number of AI engines. And so the way that we're interfacing with it is the AI engine optimizes all the sensors and optimizes the autopilot, but is capable of being removed, put a new one in, and swap it. So when, let's say, Anduril picks up their AI engine and they're moving out in one direction, we can also work with Shield AI and their AI engine as well. And nobody has to pick. The United States government, the Air Force, can pick their best capability to date. They can go out and execute with that, and then later on they can pick something else up.
This is kind of a dinosaur example here, but in many ways it's like you got your F-16. You could put a weapon skull patch in it if you need it for that mission, or you could put the new second lieutenant as a wingman if you want to. They can operate the system. They obviously will yield different things from it, different attributes, but It is really fascinating, kind of the model you're laying out.
Otis, you mentioned Secretary Kendall, and it's no secret that he's made CCAs a huge priority. So how is that changing the dynamics in the field? Past leaders have prioritized this technology, but I think we all agree it's on a different level of prioritization today.
Yeah, I do think that Secretary Kendall's emphasis on this is really changed the game when it comes to the speed that we're capable of fielding. If you look at the timeline from having an airplane to fielding an airplane in the recent past has been, anywhere from, unfortunately, 15, 20, even sometimes 20 years to get something out the door. And a lot of it has to do with the way the budget works and the timeline for the fight up and making sure that we minimize cost at the expense of time. Now, Secretary Kendall's priority has said, look, we're going to actually field these by a specific date, and we're going to bypass some of the traditional ways of doing business. We're going to take the capability that is already out there in the field, not in the field, but already out there that has been proven, whether it's an AFRL capability, whether it's the lessons learned that we had from flying UASs for 20 years. And we're going to be able to put all that together, and we're going to field version 1 of this thing in a much faster timeline. The timeline is classified, but it's way faster than the 15 years that we were talking about. You don't get that time relevance unless the Secretary of the Service is going to prioritize it and sacrifice other things, make some trades inside the FIDEP in order to move this forward.
Well, Otis, one of the exciting things that I think, and having been part of industry before, part of this emphasis will afford companies like yours the opportunity to see the aircraft fly sooner, and with the operational test community, and it's been a major drumbeat out of us at Mitchell. Stop studying this stuff to death on PowerPoint and let airmen figure it out in the real world. So talk to us about how you expect to see this unfold if you can, and how do you rack and stack from challenges and opportunities from this perspective?
Yeah, so I think I just got done saying that Secretary Kendall's moving this thing forward really fast. But from a operational perspective, it isn't fast. It's fast only when you base it off of what the traditional acquisition process is. But we have taken now 3 years from the initial Skyborg effort to now. And it looks like in 24, so now 4 years of studies and things before we're going to make a decision to actually start moving forward in an LRIP kind of production capability to give something to the warfighter. And that still is taking a long time from the time when you look at our adversaries and what they're doing. So I do think, though, that the idea of testing and getting this out to the warfighter is the thing that has been moving forward pretty quick. The Valkyrie is now flying with a 40th test down at Eglin and flying almost now as a daily flyer from a test point, an operational test point of view, to be able to understand things better, to understand the logistics that go along with the flights, to understand optimization of how you're going to do this, how you're going to put sensors, how you're going to put mission sensors that are optimized for various mission sets. And I think that is the way of the future, right? Getting this into the hands of the warfighter and letting them exercise with it. So we start with the operational test community, and then we move out. I believe the Air Force's plan then is to move into some initial squadrons of CCAs and then continue to propagate that out until you see them more and more as being normalized in the force.
So it's awesome tech, but you guys also have to meet a payroll while you're doing all this. And we're talking about years here. We're developing this technology and evolving it. You got to keep the innovation flowing. So you guys are market disruptors in a land of giants when you think about the big aerospace firms. Talk to us about what it's like to be in this space. You've got unique opportunities, but there are also some challenges for you in this regard. What's it like to live there?
Yeah, it's really fascinating. In fact, I had an opportunity to talk to the PPBE Commission about this very thing. And the idea that because of the way that we have developed our acquisition process over time, we've developed it to minimize risk, right? Minimize risk and minimize cost at the expense of time. I think that is changing, right? Because we're moving back into a competitive, great power competition kind of role. But the timeline is still long. And so you either have the primes that go ahead and are built, their whole entire acquisition process is built based off of what the department has set up. And they can handle a long acquisition process. Their shareholders accept that, and their IRAD is built for that, wait for the requirement to come out and then build off of that requirement. Then you have the mid-sized companies that are trying to fight their way through this, but the timeline that has been historically the way that the acquisition process works, it makes it very difficult for them to stay with it as this moves forward, which is why a lot of these companies relegate themselves to being tech development companies, AFRL, DARPA, those types of things, because there is the time scale is a lot quicker, but you don't actually field the product in the end. And then you have companies that are private equity or venture capital funded, right? That if you have a funding source that is patient, right, then you can withstand the time and stick with it in the timeline of historically has been the Department of Defense. If you don't, right, then you're going to be relegated to the same places that the mid-sized companies are. So the unfortunate fact is that because of our timing and just because of how long it takes to field things, we're pushing people out faster, and we're pushing them either to the primes or to private equity that long-term, like a SpaceX with space launch, right? Somebody that can withstand that timeline and don't have to answer to the shareholders on a quarterly basis.
Otis, this is something that I absolutely understand in my previous life, having had a startup that did large defense contracting. But what is the business case that you guys need ultimately to take all this to the next level?
So I think that, one, we're going to have competition where we're going to end up moving to the CCA programs that Kendall has talked about, and the timelines that it looks like they're going to be able to make some procurement decisions. We're going to compete for that, and our expectation is that we bring a discrimination for cost and a discrimination for capability to the field. And so we need that, and we're going to need to see some kind of an order for the number of airplanes. Otherwise, it'll be squandered away and it'll just sit as another program that didn't cross the valley of death.
No, and I think there's a concept here too that the department needs to be more sensitive to, and that's the speed of money. And that the department just gets kind of their annual allotment of cash from the Hill, and they burn it at a certain rate, and life rolls. For a company that has to go out and meet a payroll and keep everything, the lights on, and their staff employed, there's a certain rate of process and wickets you have to go through to get to a real program and make it all come together. You just can't keep this studied forever. And I think there's a lot of frustration right now where the department made a big call for innovation, or it was about 6-7 years ago now. And yet those things still aren't coming to fruition. And the people that did invest and make a good faith effort with it are going, what the heck, guys? You said you're going to do this. You cannot do this at a multi-decade pace here. That's insane. So it's my soapbox speech on this one. But you're also selling some Valkyries to the Marine Corps. What's up with that?
Yeah, so airpower is spread to the Navy, Marine Corps, and the Air Force, and they recognize the same thing that the Air Force did.
Top Gun 3, the Valkyrie?
Could be. I think that would be.
Tom Cruise already made a movie called Valkyrie. You have to change the name.
A different one. No, yeah, it was for a different war. So I think we'll be okay. I do think that they recognize the same affordable mass capability. I think that the Marine Corps initially started moving forward with the MQ-9 and fielding that, and now I think they're looking at what's next, and we're part of the what's next.
What's it like to work with them on their requirements, their operating concepts, their strategies, and all? And then try to adapt your tech to that? I mean, do you have to go back to clean sheet, or can you take what you have and evolve it? I mean, in manned aircraft, it's pretty hard to swing between the services, especially when you get out to the carrier and things like that with those requirements. But how are you guys seeing it in this new realm?
So I think it's domain specific, right? And so for the Air Force, how they operate logistically versus the Navy and Marine Corps. But quite frankly, the one thing that makes it work across all the services is the runway independence. Because now everybody still operates in the air, and a lot of it has to do with the logistics of getting the airplane off the ground, whether it's off of a carrier, right, or off of some non-runway area for the Marine Corps, or it's more of a ACE kind of concept, right, expeditionary concept for the Air Force. But all of those become equal when you do runway independent takeoff and landing.
That's cool. I didn't think about that.
Yeah, and Otis, for those listening that might not be familiar with this concept, can you briefly explain it?
Sure. So runway independence is obviously just the fact that you don't need a runway to take off and land. The way that the Valkyrie does that is we do a rocket-assisted takeoff. So it's launched off of a rail that comes honestly out of, so you have a shipping container, the aircraft packed into the shipping container, the rail comes out, you open the shipping container up, the rail comes out of it, snap the wings on and the thing launches. And then it recovers via parachute. You take a F-150 pickup or something along those lines, put it back on the rail with a little winch, and you're ready to launch the thing back up again.
Yeah, that's absolutely incredible. And as I think about this, it's just going to be incredible when this goes to scale into mass and what we're going to be able to launch and recover quickly. And to Doug's point, you talk about other services, and then so my mind naturally goes to the allied market. But I imagine what you just described, that the MTCR restrictions are a huge problem. And for our audience, the MTCR, that's the Missile Technology Control Regime. And it's a set of rules that the U.S. has volunteered to follow, and they're pretty outdated, and they see this UAV classified as if they're a nuclear-tipped cruise missile, and is a huge problem. So can you shed some light on that?
Yeah, so this is something we were working on the Hill as well. So the MTCR is a self-imposed restriction that we will not export our capability to other countries. And so really what we end up doing is ceding that space to people that don't have that restriction, including our allies. So we have places where our very close allies want to buy, whether it's a MQ-1, MQ-9, Valkyrie, whatever the unmanned system is, but because it exceeds an arbitrary range, I think that range is 250 miles, then it's very, very prohibitive in order to be able to export that out. And people know that. And so they'll go to other countries like Turkey and places. And you see this in Ukraine. And the fact that the unmanned systems have made a huge difference in Ukraine. Right? And I think that history will look back as Iraq and Afghanistan for us were large with drones, but Ukraine really has normalized that as when it comes to warfighting. And it's really made Ukraine air power very, very effective against the Russians. We restrict ourselves from actually exporting that type of capability to other countries. In my opinion, at least, it's not necessary. Opening that up to us allowing to give or sell our allies this game-changing technology is something that we should reevaluate.
Well, let me put a little finer point on this. What we're doing is we're driving business to China and other countries that are quite often our adversaries. And that funds their research and development efforts in this field. It amortizes their production base and all of that. This is insane. The U.S., think about the world if we decided we weren't going to sell manned aircraft. It would be an entirely different playing field out there, and it would undermine our ability to innovate and produce and drive value in relationships. It is just absolutely nuts. And so I think we need to seriously reform this set of policies.
Well said.
So Otis, you participated in some initial workshops this past summer where you teamed up with a broad variety of government and industry experts about the future CCA concepts of operations. And like you're mentioning, we're obviously going to see these things in the battle space a lot more. So where are you seeing things head from a warfighter perspective? And you were a squadron commander of an F-16 squadron back in the day. So what would your counterparts see in the future in the CCA world?
Yeah, so it's a great question, and that's one of the things that the Air Force and their tests down at Eglin are trying to figure out, that organizational construct. Because you can imagine an F-35 squadron commander, right, that gets deployed to the Indo-Pacific for operations, and there you could do it one of two ways, right? The fighter squadron could deploy with a contingent of CCA to augment, or there may be a separate organization that does launch and recovery operations for CCAs as they're spread out inside the first island chain. And I think that question of organization is really important, and it's something that we need to war game, we need to test, we need to exercise with in order to get the balance. But ultimately, when you take off, regardless of how that logistics looks on the ground, when you take off as a mission commander, you're going to take off, and my perspective would be that you'll have a group of CCA that have been mission planned with you and optimized for the mission set that you need. They'll rejoin and fly in formation just like your wingmen would today. Some of them will have weapons, some of them will have sensors, and some of them will have both. And you'll go forward and execute the mission with, let's say, 6 wingmen unmanned, as well as probably 3 to 4 wingmen that are manned, each one of them also having their own CCA contingents that go along with them. And so it really becomes a 4-ship of manned aircraft become an entire strike package in and of themselves with survivable capability that can penetrate, execute a mission set, and then nest back out and recover and do it again quickly.
That's pretty cool to think about. So we're getting short on time here, but I just want to toss a final set of questions here. So factors to consider for the future as this technology evolves from conceptual lane. We've moved past that. Now it's really the low rate production zone where we're at. And the next step then is really operational flight line mass. So how do you see that evolution occurring?
Yeah, so I see three areas where the evolution is decisions have to be made to see where that evolution is going to go. One is, do you disaggregate sensors and capability and weapons across the CCAs, or do you try to make each individual one have the same organic capability, much like you do on the manned aircraft? I think optimally the disaggregation is the way to go, in my opinion, but I do think that adds a little bit of mission complexity that we're going to have to work through and get used to as the gentlemen that are out there and the women that are out there that are flying the mission sets today. And then second would be mission specialization. Do you have CCA that are just sensors or just weapons trucks? They just do air-to-air, they just do air-to-ground, they just do seed. And that is unclear much in the same way as the disaggregated versus organic capabilities. And then finally, we already kind of covered it, but the organizational structure and the logistics. What's the optimization or the most optimized way of employing these aircraft, whether it's all in one fighter squadron, or it's their own unique organizations that are spread out through the First Island chain or throughout Eastern Europe?
Yeah, Otis, I can't help but, based on your comments, to already start thinking about this mission planning, my four ship on, hey, we're going to stop for gas at Hickam, and then we're pressing from there, and you'll meet the rest of your strike package that's already forward deployed. And either you've picked, like you mentioned, the certain capabilities. I want 6 to have seed capability, 8 to have pure air-to-air capes or weapons loadout or whatever. I mean, it's super exciting for me to think about from the cheap seats, but it's also making me think, are we going to see manned combat aircraft disappear, or is this a world where the future we're just going to have to see both coexist?
I actually think that things are going to coexist, right? I think that the optimization of the AI is going to be to augment the manned aircraft. I don't think that we're ready for, nor I think is a good idea, to have a bunch of aircraft out there that are making lethal decisions on their own. There's a big ethical discussion that goes on with lethal autonomy. That's a good discussion to have in colleges and in war colleges themselves, but I don't think it's that relevant here. I think that you want a man on the loop, right, to be able to make these kind of decisions in combat. So I think you end up bypassing that whole thing by just having augmentation of the manned aircraft. And how many manned aircraft, where they are in the fight, that can all evolve. But I don't think that you're going to see the end of the manned aircraft anytime in the future.
Yeah, and you really brought something to this discussion that we haven't really talked about, because we're so focused on policy and capabilities that even though we can, right, the question becomes, should we do it? And I appreciate that you brought that to the forefront. But, gentlemen, as always, we get to talking and we start running out of time. Can't believe we've been talking for as long as we have already about this. It's so exciting. And Otis, I hope to have you back soon. So I just really want to say thanks so much for being here. And we're really excited to be there at the future rollouts and watch what the future of air power is going to look like.
Yeah, thanks, Slick. It was a lot of fun. I look forward to doing it again. And thanks, Doug.
Hey, man. Appreciate you being here. Take care, Slick.
With that, I'd like to extend a big thank you to our guests for joining in today's discussion. I'd also like to extend a big thank you to our listeners for your continued support and for tuning in to today's show. If you like what you've heard today, don't forget to hit that like button and follow or subscribe to the Aerospace Advantage. You can also leave a comment to let us know what you think about our show or areas you think we should explore further. As always, you can join in on the conversation by following the Mitchell Institute on Twitter, Instagram, Facebook, or LinkedIn, and you can always find us at mitchellaerospacepower.org. Thanks again for joining us, and we'll see you next time. Stay safe and check 6.